All right, what do we have here? Sharp. So we're only going to be working with today we have Euclidean geometry, and then I'm only going to be dealing with only the difficult stuff in both mathematics and physical sciences. Now, let's begin. What do we have on question 10? They say here in the diagram, FBOE is a diameter of the circle with center O. So as you can see there, the straight line there is our diameter. And then chord EC produced meets line BA at A. So they meet here, this line and that line. And then they meet outside the circle. D is the midpoint of CE, like that, okay? Meaning that the distance of CD and DE is going to be equal as being shown there. OD and FC are drawn, okay? And then the last part they say AFBC is a cyclic quad. So AFB and C is a cyclic quad. Now, what is the first thing that you need to do? So you need to be able to refer to your theorems before you answer the questions. What do I mean about that? I'm checking if the theorems are how. If you don't know your theorems, then it's a bit of it's a chai for you, yeah. So you can't really attempt to do these questions without those knowledge. Now let's just break it down. Let's break down this question. The first thing is we're going to be looking at all the theorems that we can see there. Okay, so I'll start with the basic ones before we look at the first question. So let me bring this down like this. Let's make sure that everything is there. Yes. So the first theorem that we're going to be looking at there, it's going to be this one. Move it slightly here so that everything can be good. So let's look at this one. FCE. You see this one. So this is the theorem there. So the theorem states that if you have a diameter, it is going to subtend a 90 degrees there. There you go. And we call that angle at the semicircle. So this is angles at the semicircle. I know that a lot of you know this one. Okay, I'll try to write with a darker pen. And then the next one that I can see is this one. See this one? Yes, I've drawn it there. It should have a center O. Now, what do I know about this one? What I know is that it reminds me of theorem 1. Because I'm given that this is the midpoint, right? I'm given that this is the midpoint, and then A2, this distance they're going to be the same. Zizulingana. Okay, so I blow me out then. So remember that in theorem 1 you are required to prove that these lines, which is this OD, is perpendicular to that line. So here it's supposed to be E. So if you are trying to prove that these are perpendicular, on the final stages of proving that, you'll be required to prove that this is 90 degrees and this is 90 degrees, right? Because perpendicular lines form a 90 degrees angle. You see that, no? So the reason for that is because the line from the center of the circle it is going to bisect the chord which is now the CE. Is going to bisect it, meaning it's going to create the distance to be equal on either side, this side and this side. So when we construct this to become two triangles, we are going to prove that these two triangles are congruent to each other, but that is something for another time. We're not going to be looking for that too much. So the only thing that we are required to prove there is that D1 and D2 is 90 degrees, right? And then we were told that AFBC is a cyclic quad. So I've also drawn that here. So I'll show you that here. There is our A, F, B, and C. So what do we know about that? We know that this angle here, it is going to be equal to that angle here. The same as this angle here is going to be equal to that angle there. And what is the reason for that? We know the reason. Same segment. So these angles are in the same segment. So that's what we have there. Now, so is that enough for us to start? I think so. We'll look at other theorems that, as I can see there, I can see we have a bit of proportion as well, but we'll look at those ones as we move to the questions. Now let's look at 10.1.1. Prove giving reasons that reasons. No? Okay. Let's see. Where am I going to write this down? Okay, so it says FC is parallel to OD. So we need to prove that this line FC is parallel to OD. Now, how do we deal with proving parallel lines? So again, I do have that. We are going to be focusing on two things here, which is corresponding angles and alternate angles. What do I mean about that? If you're trying to prove that these are parallel, the only thing that you need to prove is angles being equal to one another, whether it's going to be in this format of corresponding angles or it is going to be in this format of alternate angles. So if you can prove when I just regular level or no, this one is equal to this one, then umnandi. Prove out this one is equal to this one, umnandi. Do you see that? Yeah? So by saying that, now you can see that the only thing that you need to prove here is that this angle here is equal to this angle there, or you can prove that this angle there is equal to this angle here, creating a corresponding angle of F. Because as far as I can see, or as far as I can look, I don't see a Z in this. Yeah, there is no Z here. Then there is no alternating angle. It's only F. Yes, it's only F. So we already proven that this is 90 degrees and this is also 90 degrees from two of the theorems that we were dealing with. We have proven that C1 is 90 degrees. The reason is the semicircle, and then we also proven that D1 is 90 degrees using theorem 1. So if they're equal, then we have proven that this is parallel to that. So how many marks there? 5 marks. So that should be a walk in a park for the first question. So now let's just write it down. Let's see how we are going to put it down. So remember, the first thing that we're going to do here, 10.1.1, the first thing that you're going to do there is tell them that you have found your C1 to be equal to 90 degrees. And what was the reason? The reason was so easy. It was because of angles in the semi-circle. So angles in the semi-circle. Can put that in brackets as well. And then now we will come and look at D1 as well. That was also 90 degrees. So D1, it is also 90 degrees. So that will be because line from center bisecting the chord. Line from center bisect the chord. Good. Therefore, your angle C1 is going to be equal to your angle D1. So these are going to be equal. Therefore, you can conclude that FC is indeed parallel to OD. And that's how you get all your 5 marks there. So now we can look at the next question, which is 10.1.2. Okay, it says angle DOE is equal to angle BAE. So we come to DOE, right, being equal to base, so BAE, right? Okay, now it means now I'm trying to make this angle be equals to that angle. Okay, so I think it will involve two triangles. It will involve two triangles here. All right, so I don't think it's two triangles. Let's look at this. I decided to redraw the structure so that I can do some demarcations there on angles that are equal. Now remember that we're trying to prove that DOE, so there is supposed to be E there, so that this angle here, it is equal to the whole angle there. Okay, so the first thing that I'm going to do, I'm going to check which other angle can I find that is equal to the whole angle there, and then the answer I do have to say this was equals to that, which is F, right? So I will take this back again and say, since this angle is equal to that angle, what is this angle going to be equal to? And as you can see, now the answer is there. This angle is equal to that angle, since we have proven that these lines are parallel to each other. So you're going to have a nice F there. Do you see that? Yes. So this is going to be equal to that. So you start here to say this is equal to that, that is equal to that. Therefore, this is equal to this one. That's what you write there. So quickly we're going to do that here. So we can say that angle A, or we can say BAE, as they've written there, BAE, because we do have two A's there. It's A1 and A2. So BAE includes both of them. It is going to be equal to angle F, which is that one there. Then after that, you're going to see F is equals to angle DOE. So the reason for saying this one, to say this is equals to this, is angles in the same segment. So these ones are angles in the same segment. Therefore, angle F is equals to angle DOE. That is going to be because of the corresponding angles. Now, because both of them they equal to F, it means they are also equal. Therefore, BAE is equals to DOE, like that. So we have proven for 4 marks that DOE is equals to BAE. Okay, now let's look at the next one. It says AB multiplied by OF, it is equals to AE multiplied by OD. 7 marks. That's mal. Okay, the first tip that I'll give you is that if you have a situation like this, most of the time this is from a congruency of two triangles or a similarity of two triangles. Now, before we interject on anything, let me just bring back the one this one here, so that we can work on that one, and then I'll just rewrite the question here. AB multiplied by OF, it is equals to AE multiplied by OD. So we're going to pay attention of those lines and check which two triangles can we take. The first thing is AB, so we can check the line AB there. There is the line AB there. See that? And then OF, there is OF there. Okay, I'm good with these two lines. And then AE, it is the length of the whole thing there. And then OD, it is this one. So by the look of things here, I do have the length of this whole thing and the length of this whole thing. So I have this line and this line. So perhaps they've used the big triangle here, which is ABE. See that, no? And then the next one, I see I have OD. See this OD. So perhaps they've used the small one here, smaller triangle, or perhaps they've used this one, FCE, and yeah, it might be the case. So what I like to do, pay attention, is I'm going to single out all those triangles together. So I'm going to choose the big one and the smaller one here, and then I'm going to write them down aside, right? So let's go and do that. We can do it just here, and then I'll just take the big one. So the big one will look something like this. There is the big one, it's out. Now let me take the small one as it is. I'm just going to put the small one. It has a smooth 90 degrees there, which is D1 there. So this is going to be D1, that is going to be E, and then this is one, it's going to be O. Then the big one, we have B there, we have E here, we didn't change anything here, and then we have A1 and A2 there, both of them there, they are inside there. Now let me check which angles were the same. Remember that this angle here was equal to that angle there, so we can ribosate. We just take it as it is to say, okay, this one was equal to this one, right? Okay, then we have a common angle here of E. So remember, when you do congruency or similarity, if two sides if two angles are equal, it means automatically this one is going to be equal to that one. So in this case, this is 90 degrees. So we're going to assume that this also is going to be 90 degrees like that. So we can see that they are very, very much similar to one another. Since we don't know the angle B there, we couldn't prove that it is 90 degrees. So we'll say they are similar to one another. Now, let's go and check if we can put that in writing. Okay, so let me just put this close by, take that up a bit, so 10.1.3. so I'm going to say in triangle ABE, right, and in triangle because I started at A, so you see I started at A and then come here and then said ABE. So I need to make sure that I start with the same thing this side. So I started here and then came 90 degrees. Don't make that mistake. So I started O because this A was equal to that one. So if I say ABE, here I'm going to say ODE. Hope we don't make that mistake. So it's going to be ODE. It doesn't matter where you start. You can start here, you can start there, you can start there. Just make sure that wherever you start, you also do the same on that one, right? So now we're going to put those statements there to say angle E is equal to angle E on both sides. That is very common. You can see that is common. And then angle A is equal to angle O. That one is proven. We just proved it. So we are going to say proven. And then the last one, angle B is equal to angle D1. So you can just say this is the third angle or some angles in it, whichever one you want to do. Okay, good. Therefore, that means that in triangle ABE, it's similar to triangle ODE, and that is angle, angles. Whew, yeah. Now, here is what I mean when I say these questions, you'll see them by congruency. Is because now this is the very, very